let's integrate 2 over the square root of 1 minus 4x squared. In particular, I actually want to do this problem using a trigonometric substitution, although if you look at it as stated, you might be able to figure out what basic integration formula to use instead of doing a trig substitution. At the end of the video, you'll definitely see which one you could use just by looking at the antiderivative we get, but it's a nice challenge problem to pause and just think about that now. But what I want to do, because I want this to be a trig substitutions, I'm actually going to do just a little bit of factoring here. I'm going to imagine factoring a 4 out. And that's a little sneaky, right? But I can factor 4 out of anything if I'm allowed to divide, so I get a 1/4 minus x squared here. The square root of 4 is 2, so the 2's cancel. I end up with a 1/4 minus x squared dx. So I see an a squared, a is 1/2, minus x squared. And so not only do I see a trig substitution, but I know that my substitution should be a 1/2 sine theta. Finding dx, I know that dx is 1/2 cosine theta d theta. So let's apply our substitution and see what happens. Let's see. 1 over the square root of 1/4 minus x squared. So 1/4 minus 1/4 sine squared. And the dx becomes a 1/2 cosine theta d theta. Let's move up here. So kind of just doing that. I can factor out a 1/4. The square root, up here, the square root of 1/4 is 1/2. So let's see, just very briefly, I'd have a 1/2 hanging out down here and a 1 minus sine squared theta under a square root. Well, the 1/2's definitely cancel. I have 1 minus sine squared is cosine squared under a radical, cosine theta. Okay, well, look at this. I end up with just d theta as an integrand. Theta plus c. And if I look at my original substitution, well, 2x is equal to sine theta, and theta is equal to the inverse sine of 2x. All right, well, at this point we can see that this is in the format of the derivative of an inverse sine. So if I take the derivative of this, I will in fact get that. And that's the antiderivative we were looking for all along.